how machine learning will affect your child's life in the future. Have a look at this. Disabled people in Idaho were informed that their Medicaid assistance was being cut, in some cases up to 30%. The result of a new budget tool, a piece of software that automatically calculated the level of support that each person should receive. Can you guess what tool or algorithm was used? Perhaps it was something exciting, perhaps it was new machine learning, perhaps it was something incredible that somehow worked out exactly why certain disabled people had more needs than others. I think when you discover the answer, you'll realize it was actually a much simpler tool. And it was a tool where the people using it didn't even get the formula right. So that 30% cut was actually made for no reason at all. And I think this is one of the key things that we need to think about machine learning, is that it's full of mystery, full of mystique. People talk about machine learning as if it's a magic area. And at the moment, it might as well be magic because people don't understand the difference. So the first thing we're going to do is we're going to have a little look at what exactly is machine learning. This example, by the way, came from the book Hello World by Hannah Fry. So we're going to split this into three parts. Firstly, what is it? What will change? And what do your children need to be robot proof? Those are the three parts I'd like to do in this presentation and really just show you how it works. So, what is it? And also importantly, what is it not? How do computers see the world? Sensors, data is input. Convert everything to binary. Everything in computers is 1 or 0, black or white. There's no room for error. Everything is one way or another. You either perform logic or you calculate something. And then you give the results. So that's the 4 steps that computers have been doing since they began, and they have been very, very effective at a lot of things. Let's have a look at something that they are very effective at. Computers are very, very good at number crunching. This is Anfield Stadium, where Liverpool play. All 58,000 people would have to do a calculation every day for a year just to... Can you work out what might be able to do that kind of powerful calculations? Do you think it's a supercomputer? No, it's your child's PS4. It can do that number of calculations in less than a second. So with all of this power around, even though computers can do a very limited amount, they can do it incredibly quickly, which means that they're able to do huge data processing. Now, sometimes human-made algorithms get sold as machine learning. This is pretty much the snake oil that's going around a lot at the moment and causing a lot of confusion as to what machine learning is. Let me give you an example. This is IBM's computer Big Blue, and a few years ago it used code. Now I don't know what the exact code was, but I've put the Python up because it's code that your students can understand and it's simple enough to think about it. So the first line you can ignore if you don't know Python. The second line literally is printing thinking, and the third line is literally waiting from 1 to 10 seconds. Okay, so all it's doing is waiting for 1 to 10 seconds, doing nothing, just saying it's thinking, and then saying that its move is completed. Now, this seems like really simple code, but in a game of chess, when your opponent is the world leader and he's thinking that that computer must be working really hard, it was enough to put him off his game and possibly put him in a position where he wasn't as confident and he made mistakes. And that's the key thing. Although these were human-made algorithms, they knew every move in his history, they knew a lot about him, and they had a lot of really good strategies that the IBM Big Blue could actually really pull off. And so, even though this wasn't really machine learning, it did help to beat a person at chess. So, if human-made algorithms are sometimes shown as machine learning, what is machine learning? Well, the first thing about machine learning is there are two ways to do it. One is supervised learning, where a human sees what's going in, helps provide some of the answers, and supervises the process. So they are given some guidance, and it's a bit like me teaching a lesson. I teach the lesson, I help the students, I guide them along. Unsupervised learning is exactly that. The computers are left to work things out for themselves and see if they can identify things. And there are two main ways of doing this. So, the simplest way is to computers to try and measure out what do they think is likely to be the nearest neighbour. So, you've got the diamonds, you've got the stars there, and you've got the heart in the middle. And it's trying to work out what is going to be the closest match. And it will literally calculate this down to the detail. The problem with machine learning is it doesn't necessarily know what it's supposed to be measuring. So it's taking guesses and measuring and hoping after many times it's learned how to do it. The other method is a decision tree. It makes decisions, so looks at conditions, barometric, overcast and rain. Now where the computer is really powerful is that it can combine lots and lots of data sets and lots of data. So in these two things the machine is trying to learn, but it's learning at a very basic level with huge requirements for data. And that's the thing, to do machine learning you have to have lots of data. Humans can learn with a lot less data. So you have a rough idea how machine learning works. You have a rough idea of what is not machine learning, what is just plain old programming. Now let's look at how these kind of applications will change your students' lives. Before we do that, let's have a little look and give yourself a chance to think about what is easy and difficult for a computer. Now, you can pause the video at this point and just write in A, B, C, D, E, and you can just do it on a piece of paper if you don't want to print it out. Okay. So please pause now. Okay, so you've had a go at the Diamond 9 machine learning. Now I want to stress that there are a few ways to do this. But for me, if I look at this and I can justify this, because depending on the complexity, different things might be tricky. So algebra is the least difficult for a computer to do. Below that is night vision, because depending on the sensors, night vision can be very easy. You've got infrared, you've got different ways of detecting light. Optical character recognition is relatively easy for a computer these days. Understanding image depth about 5-10 years ago was incredibly difficult for computers, but they've now learned to combine sensors. You're not just looking at sensors like camera sensors, you're now using things like lasers, which make that sensors much easier to work. Predicting human behavior. Now this could be anywhere, but generally I'd put it in the middle because some human behavior is very easy to predict. For example, US elections with the help of Facebook, you can get the candidate you want in. So I'm putting it in the middle because some human behavior is relatively easy to predict, others can be much more difficult. Showing empathy. Now when I talk about showing empathy, I mean fake showing empathy. There was a program written about 30 years ago where it became a psychiatrist, and it used quite a few tricks to do it, but people felt that the computer was showing empathy, even if it was just a fixed mindset in what it was doing. Then we have the next ones, understanding human languages. Huge amounts of data are available for this, so I think it's a little less tricky. But again, it is difficult for computers to understand human languages. And telling an original story, the thing about this is how good an original story is it. If you want a completely random story, it could be right down there with algebra. But if you want something that's going to feel like it's got some quality to it, that's really difficult for a computer. And finally, top of the list, frankly, dogs can outperform computers at every single step. We just don't have the sensors to really interpret smells. In fact, the computer would be far better off interpreting dog behavior than it is interpreting the actual smells themselves. So that's my interpretation of Diamond 9 machine learning. Please feel free in the comments to put your own ideas in there, because as I say, it is up for debate depending on how it's done. But it gives you a pretty good idea of what computers are good at and what they're bad at before we move on to the next step. So, this was done by the Financial Times, and they were showing some ideas about what life might be like in 2050. Future factories are likely to be smart, but with a human touch. Basically, the machines might be run by AI and machine learning. However, they're likely to need lots of data scientists and lots of data and lots of design work to get these things working, and also engineers to maintain it. At the moment, robotics is incredibly expensive for anything but the most routine of tasks. And we don't see that changing actually in the next 20 to 30 years. Humans are much cheaper and much more flexible. Scientists will be looking to develop new materials. A lot of research is going to go into biochemistry to come up with ideas, and particularly to come up with materials that degrade properly, that don't create so much pollution. AI generated inventions. Who owns them? It's going to be a big problem for IP law. And I would say this is the area, if you want to become a lawyer, you've got to get that technical understanding, because artificial intelligence, intellectual property law is definitely where lawyers are going to be required in the future. Things like conveyancing, I reckon it's got 10 to 15 years before it's fully automated, and basically it's the receptionist. There's certainly larger and larger companies happening, and slowly but surely this is happening. Technological companies are going to be in the front foot to push to recycle, because let's be honest, we don't want to be putting things in landfill. We want to be doing as much recycling as possible. And this assumes that in 2050 we actually start to at least combat global warming and climate change, because at the moment that's not looking good. But recycling is going to have to become much, much more important. Creation of a circular economy will require extreme action. Radical thinking is going to need to be how we buy and discard goods. That has to be thought about. We can't have things that keep on breaking and wastage the way we are. We simply don't have the resources on this planet to handle that. And 3D printing will transform mass production. 3D printing isn't quite there yet, but we have seen it do all sorts of things. And the thing about 3D printing is that the big limitations are in terms of the materials that can be used. Also, I would say the FT is a little bit behind the curve on this one. I think 3D cutting and those kind of processes will also be incredibly important. I've given you the facts, I've given you what we think will happen in the future. Now let's think about how it will affect your children. And I've got a few sources for this. Microsoft, who are a little biased, but probably a really good indicator in this. And I would say the majority of the tech world agrees with these. Microsoft's key skills to be employable. Digital skills. People who are able to understand how computers work, use the user interfaces. I think that's going to be incredibly important. Whether that's being a creator on YouTube, understanding those digital skills is incredibly important. Analytical skills. The ability to analyze data, to see what kind of data is useful, is going to be incredibly important. Knowing how to train a machine is going to be incredibly important. Knowing what to train a machine on, knowing if you're getting good quality information back or not. And ultimately, the ability to continuously learn. There was another very good book called Robot Proof. And he came up with 3 literacies: technological literacy, data literacy, and human literacy. Please feel free to read the book. It goes into much more detail about what goes on. But I'd like to now highlight some of the skills we teach at Garden and how those will help to make our students robot proof. Firstly, technological literacy. Well, we do a lot of this. We introduce data as an idea. We are now the first school in Malaysia to be teaching machine learning, which I think is fantastic. We also use Python, which is used widely in data science and machine learning. So Python itself is a great language, but a part of Python is something called TensorFlow, which is one of the 2 most widely used languages for this kind of data science and for machine learning. We also do teach the other language, but that's at A2. And as I say, so your students, if they take advantage of this knowledge, will be able to do machine learning themselves. And finally, we teach computer decision making. This is embedded through the entire of Key Stage 3 and is coming into Key Stage 2 in the computational thinking. So, data literacy. Most of mathematics and computer science is based around this idea of data literacy, analysing data, making sense of that data. Quantitative data sciences, including social sciences such as geography, business studies and IT and economics, they all look at quantitative data and how you can process that data. These are incredibly important skills. And finally, qualitative data in things like history and English. And if you combine computer science with English, you get the art of linguistics, which one or two of my students have gone on to do. An incredibly powerful area that would be really exciting. Human literacy. Actually getting on with people. The things that computers find most difficult is that genuine empathy, that genuine ability to get along with each other and understand each other. So friendships and family life. Reading and understanding other people's point of view. There is no better way to get an insight into the human condition than doing plenty of reading. And, getting involved with that community work, understanding other people, understanding people from very different situations. These are incredibly important things that we're doing. This one was one of the projects where we helping the Rohingya refugees. And as I say, quite a life transforming event. And those students that really put in got a lot out of it. And I would also say, maybe slightly biased here, the family that codes together stays together. Coding is a great opportunity to bond as a family, to learn together, to solve problems together. I'm sure it's not the only thing, but I'm sure it's great. As you can see in the left-hand picture, every single member of my family is involved. Thank you very much for your time. Please let me know what you think, and I'd really appreciate a subscription because I've got a lot of catching up to do with my students on YouTube. Thank you very much. Bye-bye.